We're going to start off a little bit setting the stage about deployment models in Snowflake and really focusing on one particular one, the managed application. I'll talk a little bit about how we look at that just to set the stage. And then Harish will sort of talk through a particular implementation, the IQVIA Optimizer, and then kind of talk through that. And then we'll sort of dive into the deeper, dive down into that and explore how this was implemented and some of the design decisions as kind of a case study, and then talk a little bit about some best practices at the end. So at Snowflake, we sort of started thinking about application deployment models in sort of three ways, really. First two, managed and connected, those are ones that we've been doing for quite a while. And they really relate to if the provider is running the whole thing, or if there's sort of a split relationship between the provider and the consumer, typically the consumer sort of having their own data in their own Snowflake platform. The Snowflake native application framework, just, as we announced it last year, we talked about it a little bit more this year as it now moves into public preview. And that's a whole sort of another deployment model. But what we're going to focus on is the managed application. There are a couple other sessions that are out there that are going to talk about these other models and kind of do a similar talk, diving into it. But I just want to talk about sort of what we think about when we talk about the managed application. The easiest way to think about applications is the sort of three-tiered web application. That isn't the way that all applications are built, but it's a pretty simple way to break down what's sort of going on. At the top, we have the user interface layer. That's what people are interacting with, the web page that's got the buttons and the graphs, etc. That talks then to the processing layer. The processing layer basically translates user gestures into some kind of business operation, typically involving data. And that's where the persistence layer is, where the data is managed, updates, deletes, etc. So typically, in the managed application, we have the provider owns the whole stack, Snowflake being the persistence layer. The processing layer and the user interface layer typically in cloud services. So it could be AWS, GCP, Azure, etc. It could be self-hosted that's connected from on-prem. But the idea is that the provider is giving a fully managed experience. Okay, so the data comes on in. It may be born by the provider. So it may be something that you're going on to a platform where you're transacting business with that platform, and then they've got that sales data because it was born in their environment. And there's other times where there's a data flow from consumers or third parties to bring data into the platform. Because the provider owns the whole stack, they can really push some of the logic from the processing layer into the persistence layer without having to worry about like intellectual property or anything because they own the whole thing. And then lastly, sometimes people think, well, can this work if there needs to be kind of data shared back to the consumer, or do I need to be in a connected model in that world? It is possible to add sort of Snowflake's data sharing capabilities into this model, and now you sort of share the data back over to the consumer. So that's sort of the high level piece there. There's two important things that we think about when talking about these applications, and that's really around multitenancy. So the idea of taking you as a provider, providing the data for multiple tenants, how are you going to approach that? I have sort of two places that you sort of have to think. One is choices around storage, and one is choices around compute. And in both cases, they kind of fit in the same mold. Either they get their own segregated storage or segregated compute so that each tenant is completely separate, or they get a blended pool of resources, or you can pull the data together into tables and manage it that way, or you do some kind of hybrid that allows for big customers to be handled separately than the regular, ordinary, non-challenging customers. So I just want to sort of say from a multi-tenancy standpoint, kind of things to be thinking about, because we'll get into that a little bit next. With that, I'm going to hand this over.
Thank you, Brian. So life sciences use case, just a safe harbor statement here. The next one is the commercial engagement models. They've been continuing to evolve, right? So what used to be a broad targeting for any HCPs and HEO in our use case became a precise targeting. Even from a customer journey point of view, you had a siloed customer journey, but now you have an omni-channel. What do you mean by omni-channel? You have an in-person visit or you have a digital engagement with a customer. the information which used to be pushed earlier, now it's mostly like push and pull. It's a hybrid model for push and pull, right? So where the doctors want some information, they ask for a pull of the data coming in. The interactions, again, in person versus multimodal, where we can have a precise, targeted digital engagement with the customers. Either it could be a institution or a healthcare professional. Compliance-wise, you have a proactive compliance in today's world, and performance, it needs to be adaptive, cannot be static anymore. IQVIA, as if people who are not aware of IQVIA, we have 4 businesses. I would categorize our business into 4 different sectors here. The first one, it's basically a technology-enabled clinical trial design and execution to reduce time to patient. What it means, we have a entire clinical trial business which runs and helps the life sciences industry bring the products into market, into the hands of patients very quickly, right? We help them. Real-world evidence-based innovation in clinical development, commercialization, and regulatory compliance. That's basically looking at real-world data and prioritizing what needs to go into commercial and regulatory compliance way. Commercial and technology solutions that we orchestrate stakeholder engagement across silos, right? There are different stakeholders within a commercial engagement. So we help and orchestrate the whole thing across different silos. Last but not least, your safety and regulatory, especially in our life sciences industry, we have to be careful on any solution that we provide. It has to be compliant across the life cycle. So we help them with that. Now, what does IQVIA OCE do? Basically, it enables end-to-end omni-channel engagement across all personas. You could have a field sales, you could have a brand director, you could have a compliance manager. So the whole point is right actions to the right customers, right message, and right channel at the right time, right? That's what the OCE platform provides. So if you look at the OCE platform, we have different products in the OCE platform, all built on, we built most of these products on a platform strategy, right? So if you look at that, underneath any of the products that we built in the OCE, we have Salesforce, we have Snowflake, we have Salesforce Marketing Cloud, we have MuleSoft, but all of them, we use them as a platform, and we have built our own products on top of it. So we have personal engagement, grants, digital OCE, digital connect, optimizer, etc. Everything using a platform strategy. What does IQVIA Optimizer do? Especially for life sciences commercial operations seeking to maximize their go-to-market resource, Optimizer extends the platform to redefine the territory and roster management, right? With responsive alignments, dynamic and intuitive segmentation, and agile engagement plan. So we analyze multiple sources of customer data to plan intelligent personal and digital touchpoints. The Optimizer product does. It quickly adapts to changes based on market factors and customer responses. Some companies want to increase their number of reps in the field, or they want to reduce their headcount. The solution helps them adapt to that very quickly. Or you have a customer moving out of a particular zip code. We automatically detect that and make changes to their alignment, right? We also help develop and course and correct engagement plans on demand, right? And also, if you look at who our primary users are, it's commercial effectiveness and operations leaders from both IT and business units, and secondary users are mainly regional sales leaders and brand teams. Some of the application example views, we didn't do a demo, but here, if you look at that, if you have a scenario simulation mapping as a map interface, you can pick up a particular zip code, move to a territory, or you can basically create a complete new territory from here. We have dynamic alignment rules. You set it once and say, hey, if anybody coming into this territory or into this zip code, having this particular specialty, I want them to be aligned to this particular rep, right? You define the rules and let it go. And it could be dynamic. And again, our rules could be forward-looking, say effective July 1st or effective November 1st, the rules get impacted on that particular day. We have a flexible territory management. Again, hierarchy-wise, you can define any level of hierarchy to define your territory in a field force. It has a proven track records. We have 5 of the top 10 global pharma companies using the system. We have 130 plus countries implemented, 20 plus years of experience. We support around 110,000 field reps out there for all the life sciences industry. We process around 2 billion plus account alignment almost on a regular basis, almost like a daily basis. We look at them, we optimize at a large scale. Now, why did we choose Snowflake, right? Snowflake, the main reason we have chosen Snowflake, it handles a large volume of data. What we've seen is you throw any amount of data, millions, billion, we see that there is no performance impact on that, right? Data processing query performance has been really good. We evaluated a lot of vendors out there, and Snowflake came out to be on the top of our evaluation. Cost-conscious scaling, we wanted to make sure our cost is very precise and we could track where our cost goes. Snowflake provided that capability to us. Secure data sharing, that's very important. Most of the companies ask us, like, okay, you need to send us the data. Instead of exporting the data files, we basically have a way to just use a secure data sharing either through reader accounts or their own account, and we share the data. We also have very important features of Snowflake, like cloning the database, cloning a schema, and time travel used in the product, right? It is some of the key things that we needed as part of the product features. Snowflake provided that these features, which helped us not develop anything on our own, but we used what Snowflake provided. With that, I'll leave to Brian.
Yeah, I think what we were sort of move into is that this is kind of the high-level view. Do you want to kind of lay out what we're looking at here?
Yeah. So as Brian pointed out in his first few slides, right, he spoke about 3 different layers. You have the UI layer, you have a middle layer, and you have a database layer, right? That's what this is all about. So we have a UI layer. They're basically for the end user looking into it. We have an API layer. Any interaction that needs to be done with the database, we have an API layer, either the data coming from external system, like the external data sources, or from the UI. We always go through an API layer. And API layer has multiple things. We'll discuss that in further slides. And we have Snowflake. And data sharing, pretty much we have a data sharing out to our customers or our internal products. We do data share.
All right, so let's start talking a little bit about what's going on inside of Snowflake.
Yep. So if you look at what we have done inside of Snowflake, we have a single account. We do have different tenant databases, right? Each client has their own database. And also what we have done is, if you look at 3 categories there, reporting, API, and compute, these are warehouses that we're using. So we have a separate warehouse for reporting. We have a separate warehouse for APIs that gets called. We have a separate warehouse for compute, right? And UDFs, obviously, which is common across. All this reporting, API, and compute, they are common for all the customers that uses our product, right? Except the database, everything else is common here.
So I think we talked about a little in my intro slides about sort of how to make the decisions or the choices with multi-tenancy. Can you describe sort of why you went with a database per tenant model?
Yeah. So key thing is we allow our clients to customize or configure the data model to add their own tables or own fields, right? So each tenant will have their own structure of data. So in order to accommodate that, we went with the different databases per tenant.
That makes a lot of sense. We've seen a lot of that as well. It's sort of that's one of the ones I see the most, when it's like, well, actually everybody's could be a little different. It's kind of hard to put them all in one place. So how then do you sort of onboard a new tenant? Is it straightforward? Is it
complex? It's pretty straightforward to onboard a new tenant. So from a UI layer, what we have is a single button saying create tenant. For example, here in the UI, we use Salesforce as a UI. We have a create tenant screen. Hit the create tenant. We have an API saying create tenant API. It automatically clones our base model for this particular tenant and creates a database and provides the corresponding database information and credentials back to the UI layer.
And then the offboarding is also
pretty straightforward. It's the same tenant API we can use to basically offboard the tenants.
So it's basically dropping the databases.
Exactly.
Yeah. And then the compute, you mentioned you're sort of going with the multi-tenant compute in the 3 buckets. So sort of 2 things to kind of dig in there. You chose let's just pick the API layer. So it's a multi-tenant. Why do that versus each tenant getting their own?
Yeah, it's basically cost factor, right? So what we wanted to do was the APIs get used, but the amount of time that the API warehouse has to be up and running is very short. So what we did was we have the API warehouse created so that it can scale, but at the same time, the sizing of the API warehouse is different from the compute and reporting. So for example, in the compute, we need larger warehouse where the API warehouse is a small warehouse. You just need to bring in the data or retrieve the data back to the UI. So we went with an approach. So we looked at all different components and said, okay, which ones make sense to put them together into a warehouse, right? So API was one of them. Reporting, any of the reporting thing which comes through a reporting engine or the warehouse. And compute, basically, whatever we have our rules engine running in the API layer, whenever it runs, it uses compute because it needs a larger compute capacity.
I think you touched on it, but are the reporting API and compute warehouses sized the same?
They're different. They're all different.
They're different.
They're different. Yes.
So just went through the normal best practices for right sizing.
Yep.
Yeah. Nah, that's another one that we see quite a bit. Do you use any of the multi-cluster warehouse capabilities to auto-scale?
Yes, we use multi-cluster warehouse for auto-scale for all of them.
For all of them. Okay. All right. I think then let's swim upstream to the API layer.
Okay. So in the API layer, what we have done is I've listed out the high-level APIs that we use in the API layer. The tenant API, as I already discussed, it's used to create the tenant, which means to create a database and send the necessary information back to the UI layer. The OData and bulk is used mainly from the UI layer to make any queries to Snowflake. So we don't have a query right into Snowflake directly. So we use the OData API layer to query, as well as we also have something called a bulk API, right? Our clients are giving us bulk files. So we use the bulk API to bring in the data into Snowflake. And last but not least, the rules engine. The rules engine is our heart of this whole process, which runs the calculation every time the data changes. It runs the calculation and then basically updates the Snowflake database. So that's the API layer sitting there for you.
And then how is this deployed? How do you guys?
So we use AWS EKS for deployment of this API layer.
Okay, and that gives you then the scale of
it. Yes, AWS has the scaling mechanisms there, so we use native AWS capabilities for scaling.
And then you're sort of mapping, if everything is sort of coming through a multi-tenant situation, how are you knowing that a UI, when I ask a question, everything's getting routed to the right stuff versus when somebody else?
So the UI has all the information that it needs to connect a particular client's tenant database. So it gets passed on to the OData or any rules engine, etc. And so we know, and obviously it's secure, and each tenant has their own security keys, which gets stored in our AWS Cognito layer. And then we push that information. Using that information, we connect to the right database in Snowflake.
And then you're managing that metadata separately, or is that managed of like?
Yeah, so we use DynamoDB as an intermediate store in AWS, and it's obviously secure. And that's where we store most of the metadata. And obviously, and the API layer also has a caching of that metadata so that it's much faster for us to get any of the APIs.
And then in terms of sort of monitoring, logging, seeing the whole end-to-end, how are you approaching that part?
Right. So there are a couple of things what we have done here, right? From a logging point of view, we use the native CloudWatch logging mechanism. Plus, we do write into our database logging tables also. So we have two ways to monitor that. And from alert, obviously, we use CloudWatch to alert. We also have a need for us to basically make sure we have governor limits whenever the system, we provision a system for a client. Based on the capacity that they purchased, we have governor limits. So the whole point of ensuring the governor limits, we use the monitoring mechanism to see, hey, have they reached the governor limits? For example, we have X number of API calls that they can make a day, X number of rules that they can run in a day, right? So all those things, we track that as part of this monitoring process, and we do provide that information to the UI layer or into the API layer to make sure that the client is not reaching the governor limits. And we have alert mechanism going out as soon as they reach the 90% threshold. We have alert mechanism going out, and we can obviously extend that threshold for a week, or basically if they pay us more, for us, we basically extend the governor limits.
All right. And I think the last question on the API, right, there's the connection from all those APIs into Snowflake. Are you doing that as like a single connection with a service user? Is it a connection per tenant? How is that?
So the single connection
as a service user. And then just making sure that the queries are going to the right.
Yeah. Correct.
That's another common one that we see across a lot of folks as well. All right. So then moving up, we got to get data in. Can you talk a little bit about the data sources?
Yeah. So from a data source point of view, we have different data sources, right? We have our own IQVIA apps, which basically can supply us data. So we do have, for example, IQVIA has MDM solutions and OneKey, which is our very popular data for all the HCPs and HCOs in the world, right? So we have the data. So if a client purchases that data, so we basically source the data through the IQVIA apps. We also have customers feeding in the data, right? For example, an employee, or we have a Workday connection connected to get the employee information that comes to a customer app. So for third-party apps, as Workday connecting to us to get the third-party apps. So these are mainly the three main areas how we have different data coming into us.
And if it's not a direct data share, then it's going through those API layers.
Correct. Exactly.
Right. All right. That seems pretty straightforward. How about on the UI side?
So UI, again, as I mentioned earlier, we use a platform approach. We have a UI platform, we have a reporting platform, and we have a maps platform, right? UI platform is built on Salesforce. So if anybody from a end user point of view coming in, they have Salesforce as a platform. We have obviously customized or built our product, OCE Optimizer, using Salesforce. And then from a reporting platform, we use another vendor out there. And the reporting platform in this case is embedded from a UI point of view into the UI platform. And then the connection into Snowflake from the reporting platform actually goes directly through a JDBC connection into Snowflake, right? So we have that link there. Map, we need to use maps to show the geography, the zip codes, the territory structure, etc. So we use a combination of the cloud provider like Google and others, plus we have the mapping layer to lay on top of it to show how the district looks like, how the territory looks like, or a complete region looks like on the maps.
All right. And then now at the other end, how about data sharing?
Data sharing, perfect. Again, so when it comes to data sharing back out there, so once the data is processed from in terms of the alignments, how the territory should look like, who are the customers aligned to a territory, we do that, we do the calculation, and then for the downstream system, there's multiple ways that we do that, but mainly is we do the secure data share or reader accounts, and we give the clients access to the data for their database to go ahead and query and use it in the downstream system. We also have IQVIA apps, right? We have Incentive Comps, which basically, and other apps within IQVIA, which basically needs the data here so that they calculate to the further life cycle for the life sciences industry, like calculating the rep compensation, etc. So this data gets shared into the IQVIA apps, and there we have a separate product taking over additional processing that needs to be done.
So is that other apps, are those in the same Snowflake account? Are they in a separate Snowflake
In a separate Snowflake.
So data sharing again, kind of
Yep.
to get over there. Nice. All right. I think the sort of now bring the whole thing back in. I think one of the things that's always a question is around security. And so talk about sort of how maybe the API layer gets secured in terms of allowing security from the API in or the UI in, and then maybe connecting to Snowflake as well.
Right. So we have from an API layer point of view, we have users which is created. So whether it's a UI user, we have specific UI API layer, UI API layer user created. And when it makes a call into API layer, it has to first get a token. And token basically tells you, hey, this is a valid user who's connecting to us. And once the token is provided, they use that token to make further API calls, right? And then again, the token is short-lived, and they have to basically go ahead and renew the token at that point.
Is it kind of a standard OAuth flow kind of?
It's a standard OAuth flow.
Nice. And then I think the last part's just sort of, this is the approach that you have taken with OCE. But as you're thinking about other applications, is this kind of the pattern you're thinking? Are there variations on this theme?
Yeah. It's similar to this pattern. So we have another application that we are replatforming. As part of that, we have taken, I would say, most of this layer from here, except probably the UI layer. So we have taken everything else into the replatforming of the new product.
Well, that sounds great. All right. I think the last question was really that I had was really around sort of, I think this next slide is sort of just some thoughts on best practices and thoughts around other people who are going down this journey themselves as they think to build it out. And I think these were a few of the ones you had, but
Yep.
you have others as well.
A few things, right? Design, when you're designing, keep cost of goods in mind, right? So what we initially got burnt was we never knew what our cost was. We built something and we realized, okay, cost is crazy, right? So when you're building, make sure you know where all the cost is coming from, right? Snowflake has a way to contain your cost. Make sure you use it. If you're using other platforms, make sure you know your cost before you start building any product. The second thing is you create separate warehouse for your different use cases. This way you can control your warehouse sizing and scaling, right? In our case, we had 3 different warehouses. We know certain warehouses are going to be used like 10 hours or 12 hours a day. And some of them are going to be used probably in spurts of probably 10 to 30 minutes in a day, right? So, and scaling is also different. So make sure you have different warehouses for your different needs, right? The last but not least, review all the Snowflake features offered before you start designing, right? Snowflake might already have solution for your needs. So we have seen that. So when the product owner comes in and say, I want this requirement, don't jump in. Just take a look at what Snowflake offers or what other platforms offer before you start building on your own. Some of the key things that we have started using and helped us a lot was your time travel, your cloning a database, right? These were great help for us, right? Without that, we would have spent tons of money to build something which already existed with Snowflake. So just keep that in mind.
If I remember, on the time travel one was kind of interesting. That wasn't the sort of standard sort of like administrator use case. That actually was a business requirement.
It's a business requirement. So the idea was you have the end user calling up and saying, hey, this doctor was supposed to be in my territory, but I don't see him in my territory. Why, right? So somebody has to look into it. In the past, what we used to do was we had to look into multiple data files and see what data changed because of which the doctor got unaligned from this territory. Now all we have to do is go through time travel, and it'll tell you, hey, the specialty of the doctor changed, or your zip code of the doctor changed. That's why he got moved from one territory to another territory, right? So that's very, very helpful for us. And even from our client's point of view, they can compare it and say, hey, on this date, the data was this way, and the second day it got changed, and that's why it got realigned. So that's very important feature that we had. The other thing is on the cloning database also, guys, we have a lot of requirements where the companies don't want to make the change immediately, right? So they are trying to create a new structure for them, new data structure going forward, right? January 1st, 2024. Now they want to simulate the model for them and see, hey, how does this model look like? Try different models. So what we do is at that point, every time they want to simulate, we create a clone of the main data that exists. And when we create a clone, and the next all operations are taken on the cloned schema. So what it helps us to do is the production data is kept separate. We have a separate cloned schema which operates on where we can operate on. They can do whatever they want, try out different scenarios, try out different simulations, etc. Once they're satisfied with that and say, hey, this all looks good, I want to commit this change. They hit and commit, and that's when we basically take the data and push it into the main database.
Yeah, I think if folks aren't familiar with the cloning, the zero copy cloning idea is that you can kind of take a table and like fork it. And so you can, and that doesn't require copying the data. So from there, in this example, for instance, you could have people sort of go, let me experiment by changing my copy of the data. Meanwhile, the production copy is marching along.
Perfect.
And then you can choose later on to sort of incorporate and bring things back together or not, right? You might decide, actually, that was a bad idea. Why don't we just drop that whole thing and try again? And so it's a really interesting, it's another one of those situations where both of those examples, I think, aren't exactly why we built it in the first place, but it's part of what I really enjoy about looking at people's architectures is you sort of use some of the tools that we put in the toolbox, not quite the way we were intending, but totally valid. Like it was just an interesting other use case. So thanks for sharing those. I was curious on the different use cases. If I go back for a moment, do you have situations where the different, like a single action on the UI might have to sort of bridge multiple of these warehouses in the same sort of like an API says, I'm going to contact the reporting warehouse or not. We see that sometimes where an API call will call out to different warehouses because one part is heavy and one part is light. Or is your environment more simple than that?
You would see that, right? There are some certain scenario simulation which happens where if you're simulating a scenario, I would basically hit the compute API as well as reporting at the same time, right? I want to basically give a instruction to compute. At the same time, I want to retrieve the status of the scenario simulation. At the same time, I want to see, okay, what did the compute do? What's the end result, right? I'm basically hitting all these 3 times at the same time.
I think that's another interesting one to call out is like if part of it is really cheap, use a low warehouse and save some dollars. And if it's really complex, let's get the right sized warehouse so you get the user experience you want. Let's just repeat the question. So the question was really around the costing model and how the costing model for the tenants comes in, where some tenants are big and very active and some might be small and less active. How did that manifest?
Yeah, there are two ways to look at it, right? One, as I mentioned in the UI layer, we set a governor limit. Suppose a client comes in and say, I have 500 territories, right? So they buy the capacity for 500 territories. Another client comes in and say, I have 10,000 users. So they buy the capacity for 10,000 users, right? So at that point, their governor limits for 10,000 users is much bigger than the 400. So we know the 400, what they're paying for and what 10,000 users are paying for.
So Harish, are you solving that problem then really at the API layer? It's like charged by API call, not necessarily Snowflake usage.
Correct.
Yeah. So I have seen other scenarios where people do Snowflake usage as the way of doing things. You can do that like maybe in a chargeback model based on the amount of storage. I mean, you can definitely see if it's, especially in these multi-tenant or these tenant tables, you can see how much space they're taking up. It gets a little bit more complicated to look at the warehouses because you have all these different, in this model, you have all these different tenants coming on in. How much of that last hour was tenant 1 versus tenant 2? It's one of the reasons people do move to having a tenant, a warehouse per tenant. The challenge, I think, with that is that's a nice way to get to capture that cost and charge back. But like Harish was saying, that's not the most optimal way, the cost-effective way for, say, IQVIA to do it. Because if you pool everybody together, all the little inefficiencies kind of get amortized away. And so, we do, for instance, the warehouse will auto-suspend, but we wait a minute or 5 minutes. I mean, you can set it. We wait to make sure that you're not about to just ask a question again. Well, all those little 5 minutes on every little tenant, they add up. And so if you put them all together, you can kind of smooth that all out. But that's another way that we've seen it. It's more complicated.
Yeah, it also doesn't mean that we did not think through that. So if there are clients who come in and say, I want my own separate warehouse for this, so it's pretty easy. So we can say, hey, when we're setting up a tenant, we can say, create separate warehouse for this tenant, and then there's a separate warehouse created for this tenant. But so far, we do not have anybody coming in and asking for that. All the API layer is common across all tenants.
I realized I did have a slide at the very beginning. I was talking about that, but I have to go through the whole presentation to get there. But oftentimes we see a hybrid, right? So sometimes even when we do multi-tenant tables where all the tenants are put together and there's like a tenant ID, there'll be one really big customer or one really active customer, and it makes sense to kind of cut them off and put them in their own tables. Same with the warehouses. And so you sort of play these, very often we see people start one way and then blend for efficiency or, the experience, et cetera. Usually for an upcharge, kind of like Harish is saying.
Yep. Thank you, guys.
Thank you very much.
Thank you very much. Thank you.